Hello class, my name is Erica Johnson and today I'm going to be talking to you about my Florida microcosm experiment that I've been working on for the last 7 weeks. I will be covering my hypothesis, the methods and materials I used to create my microcosm, some key observations I made throughout the 7 weeks, as well as some major findings. To sum it all up, I'm going to talk a little about what we can learn from these microcosm projects. After building my microcosm, I hypothesized that it would fail. I thought my single point of failure that could lead to the rest of the system collapsing was the fact that I only put one plant inside. Once the plant died, I hypothesized that other living organisms inside the microcosm would die as well, since there wouldn't be anything to keep the oxygen cycle going. Next, I'm going to talk about the methods and materials I used to create my microcosm. I used an old juice jug from my trash can to build it. It was approximately 18 centimeters long by 13 centimeters wide and 28 centimeters tall. Its carrying capacity, according to the label, was 2.63 liters. I evenly distributed the amount of sediment, water, and airspace by height and not volume. Then I picked the smallest plant I could find in the same area, which was a thin grassy reed around 2 feet long. Then I had to trim it down so it could fit inside of the container. Lastly, I screwed the lid down as tight as I could and placed a microcosm on a windowsill in my house that would receive almost as much light as the original location. On a last note, I pulled off all but one sticker for entertainment purposes, but I don't believe it had any impact on the microcosm. I just thought it was funny to walk by and see a fresh taste sticker with a pretty disgusting looking jug on my windowsill. This picture gives a snapshot of the ecosystem I used to build my microcosm. I live in the Panhandle area of Florida in Panama City, within a half a mile of St. Andrew Bay. There is standing water almost year round where I made my microcosm, though occasionally dries out when we don't have rain for a few weeks. The red arrow on the picture points to the type of plant I used for the microcosm project, as where the water is actually sitting. Can't see the water in the picture, but believe me, it's there. This image is just for a frame of reference for you guys to get a better idea of where my microcosm came from. That's the ocean in the bottom left of the picture, and then it meets the fresh water in the St. Andrew Bay. You follow that north to where the yellow arrow is, and that's where the microcosm was made. According to the World Wildlife Fund, Panama City is considered a temperate conifer forest. Moving on, I'm going to talk about some observations I made during this experiment. It took a week or so of settling until I was able to see any organisms inside my microcosm. I found one small beetle and about a dozen worms. These worms were incredibly small in diameter and ranged from 1 to 3 inches in length. They were practically translucent and you could see the food being processed through their body. It was pretty cool to look at. They're pretty much clear except for that line of sediment or debris that's inside of them. It's kind of like a little zigzag line. By the end of week 3, I couldn't find the beetle, so I assume it didn't survive because of lack of food or maybe depleting oxygen levels. There was also some algae and small bubbles beginning to form on the surface of the water. By week 5, the worms were coming out of the sediment and water and were clinging to the walls of the container and hanging out in the handle of the container as well. The algae was also starting to thicken and a thin film was forming on the sides of the walls where it touched the water. By the end of week 7, I could only find one tiny worm and the bubbles on the water were about the size of a quarter in diameter. The floating debris inside the container was also beginning to look rather fuzzy. So next I'm going to go over some of the major findings. First off, on that image on the right, you can kind of see the worms sitting there in the handle and on the side is the container. Just thought it was kind of a neat picture. So I believe my microcosm failed because it wasn't sustainable for the organisms living inside. The plant was still alive by the end of the project, but just barely, and then same with the organisms living inside of it. I think this failure highlights the importance of autotrophs in an ecosystem as well as the delicacy of the ecosystem. Small changes, such as the cooler indoor temperatures of my house, showed the inability of the microcosm to adapt to a significantly different environment. There's probably about a span of 20 degrees difference. I keep my house around 73, 74, and it's been in the mid to high 90s for the last 7 weeks. Lastly, I learned that I should have tried to recreate the same proportions of sediment, water, and air. The water in my microcosm was deeper than the typical water depth outside, which I believe is one of the reasons why the plant was beginning to die, aside from the fact it couldn't actually grow to its natural length. So what can we learn from microcosms? Microcosms represent a snapshot of a real ecosystem under different environmental conditions. This information can be used to predict possible future outcomes of any ecosystem as a result of climate change. It also allows individuals to experiment and test a hypothesis without causing any damage to the environment. On a last note, the short period of time it takes to build and monitor these microcosms in different situations gives a key advantage to understanding how climate change may impact the ecosystem in the future, whereas climate change naturally should take a course over a long period of time. This concludes my presentation, and I hope you guys enjoyed it. I had a lot of fun learning from all of you in this class and wish you all the best luck in your future, and look forward to ever working with you guys or taking more classes with you again. Thank you very much.